What I want to do now is take a look back at the frequency distributions that we talked about at the beginning of this section. Sometimes this is going to be all you have. If you're reading a journal article, for example, it's unlikely that you're going to have access to the actual data, right? All you're going to have would be a summary of the data like you see in this frequency distribution. So what I'd like to do is come up with a way to infer what the mean is from the information that we have available. Now, before we go any further, I want to be clear. We can't actually get the exact value from here. The best we can do is to come up with an approximate value. And to do that, we're going to play off of the formula that we already have. Remember, the mean is equal to the sum of the data values divided by the number of data values. Now, we actually know the number of data values. Remember that the frequencies are counts of the number of values in each grade range. So if we add all these up, right, we add up across all of the grade ranges, that's going to give us the total. That's what the sigma f here in the formula represents. It's the same thing as the n in our previous formula. Right now, it's in the numerator that we're going to have to use an approximation. What we're going to do is we're going to take the midpoint of every interval. That's the m here in the formula, and multiply that by the frequencies, the number of values in that interval. If we add those up, we'll get an approximation of the total of that sigma x from our original formula for the mean. All right, so let's see how that works for this distribution. You see, you know, I like a good table, right? It helps me to organize everything. So the first thing I need to do is I need to calculate the midpoint of every interval. So this one, for example, will be 1 plus 10 divided by 2. That's 5.5. Then 11 plus 20 divided by 2. That's 15.5. And if you notice, look at the upper class limits: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. They're consistent. All of the class sizes are consistent. You can check the lower values as well if you like. That means that, like we saw earlier when we were talking about frequency distributions, these midpoint values, they're going to differ by the class width. The class width is 10. So I started at a 5.5 plus 10 is 15.5 plus 10 plus 10, and I'm just going to keep going and fill in this entire column this way: 65.5, 75, 85, and 95. Okay. The next column is f times m. So all that is, right, that's multiplying the two columns together for each row. So the first three are easy because the frequencies are 0. 0 times anything is 0. 2 times 35.5 is 71. 1 times 45.5. 2 times 55.5. That's 111. 4 times 65.5 is 262. 5 times, this is 377.5. 9 times 85.5, this is 769. And finally, 95.5. So if we add all of these up, right, that's the sigma part of the formula. This is 1732. Then over here, I'll add up all the frequencies. That's 10, 19, 20, 24. So my approximate value for the mean is 1732 divided by 24, which is 72.2. There's my approximation. And if you look at the data, right, you see that the data is kind of clustered in this range here. So yeah, okay, that does feel like a reasonable approximation. All right, so I've got another example here, a little smaller, for us to practice with, right? If you like, you can go ahead and pause the presentation, go ahead and try to work this one out on your own, then come back and we'll do it together. All right, so first I need the midpoints. 5 plus 3 divided by 2 is 4. 6 plus 8 divided by 2 is 7. And now I'm going to add the class widths, right? 4 plus 3 is 7. 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. Now multiply across, right? Do this f times x. 5 times 4 is 20. 7 times 3 is 21. 2 times 10. And 4 times 13, that's 52. Now add up the two columns. The sum of the f values is 14. The sum of the f times m values, let's see, 20, 40, 60, 113. So my approximate value for the mean is 113 divided by 14, which is 8.1, 8.07, right? We'll round it to 8.1. Right, so there's my approximate value for the mean. And again, I want to emphasize it is just an approximation. So it's probably a pretty good one, right? This is a fairly accurate formula, but it isn't exact. Okay, so how about standard deviation? Well, look, there's a formula for standard deviation. It's not very pretty, being honest about it. And I'm not going to actually walk through this, but we can talk about it real quick here. You know, it's very similar. The formula for the mean had sigma m f. This one has sigma m squared f. And this bit here, remember, this is a constant. Right, this is a constant. I've gone back to using n. N is the sum of the frequencies. Putting n in there made the formula look a little neater, right? But that's all that is. So this is the sum of the frequencies times the mean squared. So you're going to have to go through that mean process first, right? Get the mean of the distribution, then you can come and work out the standard deviation if, for whatever reason, you really need it. Okay, so that's this kind of ends our discussion of measures of center, right? That was the mean, median, and so forth, and our measures of variance or distribution. Right? That was the range and the standard deviation. And then in the next couple of lectures in this series, we're going to talk about what are called measures of position. Right? Suppose I give you a data value, and I'd like you to give me some idea of where that data value lies within the data as a whole.